Okay, in this video we will solve the following 4 problems, 1a, 1b, 2, and 1. Problem 1a says, what function f of t has u2 shifting equal to this function? Essentially here we want to find the original function and the u8 shifting is given. In order to do that, we need to forget about the Heaviside function, and anytime we see that t, we replace it with t plus a. Then in this case, a is 2, it will be t plus 2 minus 2. And then the answer would be 3 times e to the 2t. Okay, this is the answer for the first one. The 1b is similar. We want to find the original function and the u8 shifting is given. Then what we do is let me write that, forget about the Heaviside function and change t with t plus a. Notice that it's change t with t plus a, not to multiply by t plus a. Then, in this case, I forget about this part, and then the answer will be 2 times t, a is 4, a plus 4 plus 1. Then, in this case, we have 2t plus 8 plus 1, and it would be 2t plus 9. This is the answer to problem number 1b. The answer to problem number 2, here the original function is given and we want to find the u3 shifting. Then the procedure is you write the u3 of t, and then instead of writing the original, you need to change the t with t minus a. In this case, a is 3, and it will be 3 times t minus 3 plus 5 minus e to the 2 times t minus 3. Please do not forget about this parenthesis. Then when we want to find the u8 shifting, we have to add the Heaviside function, and anytime we see that t, we change it with t minus a. And when the u8 shifting is given and we want to find the original, then we have to forget about the u8 of t, the Heaviside function, and anytime I see that t, I need to change it with t plus a. Let's do the last problem. Here is to solve this differential equation. Then we apply the formula for the Laplace transform of the derivative. Is s times Laplace transform of y minus y of 0. We are applying the Laplace transform in both sides, plus Laplace transform of y equal to the Laplace transform of u1 of t times 3 e to the 2 times t minus 1. And here we can combine these two, and we have s plus 1 Laplace transform of y minus 1 equals to, the formula says that the Laplace transform of the u8 shifting of a function is equal to e to the negative a is 1 in this case, times the Laplace transform of the original. But how do I compute the original? We forget about the Heaviside function, and anytime we see that t, we replace it with t plus a, t plus 1. Then we end up with 3 times e to the 2t. T plus 1 minus 1 is just t. And then we have that s plus 1 Laplace transform of y is equal to 1, and move the 1 to the right, plus e to the negative s, and the Laplace transform of 3e to the 2t is 3 over s minus 2. And from here we get that the Laplace transform of y is equal to 1 over s plus 1 plus e to the negative s times 3 over s plus 1 times s minus 2. We need to compute two Laplace transform inverse. One is the Laplace transform inverse of this part, which is easy. This is the Laplace transform of e to the negative t. And the other one is the Laplace transform inverse of this. Let's do that part here. In order to compute the Laplace transform inverse of this expression, we need to do partial fractions. In this case, is a over s plus 1 plus b over s minus 2, and this is a times s minus 2 plus b times s plus 1 over s plus 1 times s minus 2, and this is equal to as minus 2a plus bs plus b over s plus 1 times s minus 2. And in order to find a and b, we set up the system of equations. We want the coefficient of s on the right is a plus b, and we want that to be equal to 0. And the constant coefficient here, we have negative 2a plus b here, and the constant coefficient is 3. If we multiply this, the first equation, by 2, and we add, then we will get that 3b is equal 3. That means that b is equal 1 and a is negative 1. That means that I can write this as a is negative 1 and b is equal to 1. All of this was just to be able to rewrite this expression like this, and this is the Laplace transform of negative e to the negative t plus e to the 2t. Okay, I can write down this information here, and this is e to the negative s, the Laplace transform of e to the 2t minus e to the negative t. And finally, using the formula that allows us to take care of the e to the negative as, we know that this is the Laplace transform of e to the negative t plus, when this disappears, we need u1 shows up, ua shows up, and then times, I have to, this is the original, I have to compute the u1 shifting, which is u1 of t, times e to the 2 times t minus 1 minus e to the negative t minus 1. That means that the answer is y equal e to the negative t plus u1 of t times e to the 2 times t minus 1 minus e to the negative t minus 1. This is the answer. Okay, this is it for this video.